All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. And as promised, we are back and we're moving on to a new concept today. Warm-up number 69 is on the screen, and it reads, number one, rewrite each expression. Part A is 2 to the negative fifth power. B, 1/2 to the negative third power. C is 2 square root of 2. Number two reads, if x to the third times x to the fifth is x to the 3 plus 5, which is x to the 8th, then rewrite 2 to the x minus 4 power. Number three, rewrite part A is 9 to the 1/2 power, B to 64 to the 1/2 power, and C is 27 to the 2/3 power. Number four, it says graph the parent function f of x equals 2 or base 2 to the x exponent, then transform using g of x equals parentheses 2 to the x minus 5 exponent, close parentheses, plus 3. And then a quick intro to trig. We have number 5, identify sine, cosine, and tangent of angle A. And then you are given a right triangle. The right triangle, the 90-degree angle is labeled as C. The other two angles are labeled B and A. The longest side, which is across from the 90 degrees, labeled 5. The other sides are legs and labeled as 3 and 4. From there, I'm giving you the trig functions. For sine, it's equal to opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. So I'm going to do a soft intro to that, and I'm going to get started for the sake of time. Today, we only have 30 minutes to cover our concept for today, so here it goes. Number one. Rewrite each expression. So 2 to the negative 5 becomes 1 over 2 to the 5th, which is simplified to 1 over 32. B, 1/2 to the negative 3 is the reciprocal, which is 2 over 1, and each have an exponent of positive 3. So this is 8 over 1, which is 8. For part C, last week we did practice with it and we just multiplied it inside, but today's is going to be a little bit different, but we know how to get the factor of 2 inside by squaring it, yes? So then we rewrite it as this, square root of 2 times 2 to the second. And I'm going to write the invisible exponent of 1 of whatever was inside. So if they have the same base, this becomes square root of 2 to the third. And to change this to an exponential expression, check this out, this becomes 2 to the third exponent times half exponent. Why is that? Because a radical is half, which means if we multiply those two exponents, this is base 2 to the 3/2 exponent. All right, number 2. Let me rewrite 2 to the x minus 4, which is 2 to the x times 2 to the negative 4. So this is 2 to the x over, because we can't have a negative exponent, over 2 to the positive 4, which simplifies to 2 to the x over 16, because 2 times 2 times 6. Part 3, 9 to the 1/2 becomes square root of 9, which is 3. 64 to the 1/2 is square root of 64, which is 8. 27 to the 2/3, we cannot write a radical unless we rewrite the exponent. So this is 27 to the 1/3 times 2. 27 to the 1/3 becomes cube root of 27. And then we need to raise that to the second power. Cube root of 27, or a number times itself 3 times to give us 27 is 3. So the second power is 9. All right, number 4. Number 4 is a parent function. And for the sake of time, we don't need a table. I'm just going to graph the parent function of that exponential of base 2. If it doesn't have a constant, then the asymptote goes through 0, 0. And my exponential should look something like this. Okay. So if that's true, according to the transformation that they give us, the new asymptote is what? Positive 3. Positive 3 somewhere up here. There it is. And the transformations or the parameters given are the 5, which is going to take us 5 steps to the right, and the 3, which is going to take us 3 steps up. So we take the entire function, move it 5 to the right and 3 up. So it should be somewhere over here. And that should have been practice on what you did for homework, yeah? Yes, Mr. Q. All right, good. All right. So students, trig functions students. Here goes the process, the basic process of doing or identifying the values for those three basic trig functions. Okay, so here we go. I'm going to start with angle. My bad. You are given a right triangle. So here's a right triangle. The first thing to do is identify the longest side. The longest side is always opposite to the 90-degree angle. And I'm going to highlight it in green. There it is. And that's known as our hypotenuse. I'm just going to write H. Okay. That is always the case for any right triangle. However, the second part, you need to identify the angle that they're referring to. What angle are they referring to? They're referring to angle A. Angle A is down here, and I'm going to circle it, including the angle and the letter. There it is. And notice I do that because it forms an angle here. What? Mr. Q, I'm telling you, I got this. All right. Now, according to that angle, we're going to look at the other two sides, aside from the hypotenuse, to see which one is opposite and which one is adjacent to A. So the one opposite to A is completely across, which means this one that's labeled 3 is our opposite. I'm going to do that in red. And the side that's next to the angle A, aside from the hypotenuse, is 4. And that one is our adjacent side. Now that we have everything labeled, we're going to use these three basic trig functions, and I'm going to write them in shorthand. Shorthand reads like this: sine without the E, with an angle symbol of A. We need to make a fraction. Same thing for cosine without the E, shorthand angle A equals fraction. And tangent, shorthand for tan for tangent, angle A, and I need a fraction. So here we go. According to what it says, to sine, to get the sine, we need a fraction that's formed by the opposite over the hypotenuse. What is my opposite? The opposite is 3. And what is my hypotenuse? My hypotenuse is 5. For cosine, it reads adjacent over hypotenuse. Adjacent being what? 4. And what is the hypotenuse? The hypotenuse hasn't changed. It's still 5. To find the tangent of angle A, it reads opposite over adjacent. What is our opposite side? Our opposite side is 3. What is our adjacent side? Which is 4. And that's how you identify your sine, cosine, and tangent of a right triangle. Pretty simple, right? Straight up. You're like, yes, Mr. Q. I know, I'm telling you, it's just math, guys. All right, so once again, everybody go like this. Bear with me, because today it's gonna go like this. So make sure you loosen your wrist. Here it goes. Our objective for today, our agenda for today is warm up number 69. We're introducing today logarithmic functions. We're just doing the basics. And then from there, we're moving on to your home play for tonight is pages 755, 756, but you're only going to do numbers 5 through 15 only. 755, 756, numbers 5 through 15. And you can find those in Canvas. I opened up a new module titled Logarithmic Functions. You can find it there. Your synchronous code for today, make sure you write this down because I'm going to, like I said, I'm going a little bit fast and some of you are going to fall behind. I can predict that. Here it goes. A synchronous code for today is GPX8W. GPX8W. Make sure you write that down. GPX8W. Your home play last time was pages 662, 663. You can turn that in once we're done with the session today, because I left it open till noon. So you're going to have a, yes.
You go back to the synchronous code.
Okay. GPX8W. Once again, I'm not going to be able to go back, so stay focused, please. Please, pretty please, because I don't have the time to go back and forth. So GPX8W.
Thank you.
Your home play for tonight, 755, 756, numbers 5 through 15 all only. 755, 756, numbers 5 through 15 all only, and that's going to go in your within Canvas and the new module, which is logarithmic functions. All right, let's get started. Our objective for today, I can define and evaluate logarithmic functions. I can define and evaluate logarithmic functions. Now, logarithmic functions, guys, have been misunderstood by some, and it creates some confusion. But basically, I'll give you the definition a little bit, but basically it's just what we did with exponentials, but the inverse of them. And there was no other way of describing it than to call it log functions. So today we're going to define it and we're going to evaluate those. So here we go. What are logarithmic functions? In short, they call them logs. What are they? Definition. They are the inverse of an exponential function, where b, still the base, has to be greater than 0, but it cannot equal to 1. B, which is the base, has to be greater than 0, but not equal to 1. And this is what they look like. F inverse of x equals to log with base b of a number. And here is x equals to log base b of a number. So you're like, oh my goodness, Mr. Q, those look kind of weird. I know. That's why I'm going to try first to do a quick intro so you can see what they look like. Then I'm going to give you a definition in my words to see if that makes sense. All right. What do they look like now with numbers? We have f inverse of x equals log with subscript 5, which is the base of number x. Or another one could be 3 equals log subscript of 4 with number 64. And the subscript, once again, is our base. So look at those examples. That's what logarithmic functions look like. These are already using numbers. Okay, so let me go back to the definition. It says it's the inverse of an exponential function. Exponential function. So think back to when we did exponential functions. What did we say the b stood for on exponentials? It stood for the base, yes. So that, if you notice, we still have a base. So by looking at this form, look up. If this is b, what is the base for these two? Well, the base for this one is 5, and the base for this one is 4. Okay. So this is what they look like. Let me show you what they are not. We have 5 parentheses 2 to the exponent of x minus 3 close parentheses plus 4. And this second one is f of x equals x to the second. So look at the examples and look at the non-examples. What is the one obvious reason why these are not examples of logarithmic functions? What do you think, Avery? What is the most obvious thing that you can say that these are not log functions?
They don't have log.
They don't have they don't have the word log, exactly. So what does that tell us? That whenever they give us a log function, it has to have the word what? Log in it. Yes. The second thing, I don't know if you guys notice this first one does not have an equal sign. That means it's not a function. So what does it have to be? It has to be a function. Okay. And this one, once again, it doesn't have the word log. So hashtag, of course, the most obvious is log. I'm going to give you some other ones just for the sake of time. Hashtag, it has to be a function. Hashtag, it has a base, which is b. And the last hashtag is, what do we use all these for? It's to solve for an exponent. We use logs to solve for exponents. You're like, okay, yeah. So now let's talk about inverses. What's the inverse of multiplication? Division. What's the inverse of addition? Subtraction. What's the inverse of division, multiplication, and so on and so forth. And then what's the inverse of square root? The inverse of square root is to the second power. What is the inverse of something to the third power? Or cube root. Okay, so we're getting there. But then we get to the point of an exponential where it has 4 to the x power. How do you solve for the x power? Well, they came out with this known as logs. Okay, so here goes my definition. Let's see if it makes sense. Look up. I wrote a logarithm is an actual question. You're like, what? Yes, check this out. A logarithm is saying, to what exponent does base need to be raised in order to get a given number? Let me write it out so you guys can see it. Look up. To what exponent does a base need to be raised to get a certain number? So I want you to copy this table, and we're going to translate these to exponential functions first so that you understand all the components. So I want you to write this here on the first column. The first column is titled logarithmic function, and the second column is titled inverse of log, or in parentheses, exponential function. So the reason I want to go that route first is so that we can identify all the components of a log function. Once again, my definition, the way I see logs, is like a question. The question that is asked is, to what exponent does a base need to be raised to in order to get the given number? All right. So here we go. I'm going to write the translation here on the exponential function. Ready? Here it goes. By looking at this log, my base is what? B. My exponent is what? X. And what is the given number? The given number is A. You're like, okay, I'm starting to see it, Mr. Q. Yeah, because we've been working with exponentials, haven't we? Yes. All right, now let's look at this now, but through the lens using numbers. Let's see how it looks with numbers. Copy this one. X equals log subscript 2, and then 64 is our number. So let's write that log as an exponential to make sure we identify all the components. What's our base? Our base is 2. What's our exponent? X. And what is the given number? The given number is 64. You're like, oh, okay, I think I got it, Mr. Q. Okay, well, let's see if you can do this next one by yourself. X equals log subscript 5 and 125. All right, what's our exponential function for this one? Manny, go.
It's 5x equals 125.
5 to the x exponent equals 125. Yes, that is correct. Hands if you got that. Yes. Okay, let's do some more practice. Copy this one. Example 1, it says rewrite the log as an exponential. First, we're still practicing writing it as an exponential. But notice I took away the colors to see just if you can now go a little bit faster with these. All right. So we have x equals log subscript 4 to get 16. So my base is 4. My exponent is x. And what is our given number? 16. Okay. Let's do another one. Example 1Q, x equals log subscript 3 to get 81. Rewrite that one, please. All right, Zach, what do we get as an exponential? Go. Okay, guys, we don't have like seconds to wait. So the base is 3, exponent of x, and it should be equal to 81. Let's do another one. Copy this one. Example 1 super Q. And it reads x equals log subscript 2 to the 1/4. Give us the exponential function, please, Viv.
2x equals 1/4.
2 to the x equals 1/4. Yes. All right. So far, so good. Yes. So now that we got enough practice, let's see if we can go backwards now from exponential to writing a log. Here we go. From exponential, example 2, it says rewrite the exponential function as a log, and they give us base 2 to the x exponent equals to 32. Base 2 to the x exponent equals to 32. Here goes how to write it as a log. You start off with your exponent. What is my exponent? X. And then after that, to make it into a log, you write equals log. That's automatic. You start with the exponent, and then you write equals log, and then you just fill in the rest of it. What is our base? Our base is 2. And what is the given number that we need to find? 32. All right, let's do another one. Example 2q reads, rewrite the exponential function as a log. We have 4 to the x exponent equal to 64. Once again, I'm going to write it with colors just to make sure we see it. Exponent of x equals 2 log. And what is my base? My base is 4 and given number 64. So far so good? Yes? Okay. All right. So now that we're done with enough practice of writing back and forth, let's solve one. Copy this one, example 3. Solve for x, and we're given x equals log subscript 2 to 1/8. Now let me give you 3 basic steps to follow in solving a logarithmic function. Step 1, rewrite. Step 2, same base. And step 3, write equation and solve. Here it goes. If it's a log, I need to rewrite it, which means I need to rewrite it as an exponential. So my base is 2, my exponent is x, and I need to find it to give a number 1/8. That's step 1. Step 2, they need to have same bases. They don't at this time. So this is telling me that the base for this one has to be what? 2. So 2 times what gives us 8? 4. 2 times 2 is 4. So this could be written as 1 over 2 to the third. And we still have 2 to the x over here. It's almost the same base. I need to bring this to the numerator so that we can have the same base. This is what? 2 to the negative 3 equals 2 to the x. Do they have the same base? Yes. So lastly, we focus and zoom into the exponents to write our equation. X equals negative 3. And that's how you solve a logarithmic function. Let's do another one. Example 3q. X equals log subscript of 3 to find the number 1 over 81. All right. It says solve for x. So what's our base? Our base is 3. Our exponent is x. And to find the given number 1 over 81. All right. So this is saying that they're going to have the base of what? 3. So 81 divided by 3 is 27. 27 divided by 3 is 9. And 9 divided by 3 is 3. So how many 3's do we see? 4. So this could be written as 1 over 3 to the 4th. And all that equal to 3 to the x. However, they're still almost looking the same, except for this one is in the denominator. I'm going to bring it to the numerator. This is 3 to the negative 4 equals to 3 to the x. Do they have the same base now? Yes. What's our equation? Our equation is x equals negative 4. All right. One last one. Copy this one. Example 3 super q, x equals log 4 to the 64. See how you do with that one. All right. So what's our base? Our base is 4. What's our exponent? X. And what is our given number? 64. Now, according to this, the base has to be what? 4. So 64 divided by 4 is 16. 16 divided by 4 is 4. So how many 4's do we see? 3. So that's 4 to the third, which is 4 to the x. So my equation should be what? X equals 3. All right. All right. So far, rewriting from exponential to log, from log to exponential, and solving. How do you feel with those so far? Let's see. From 1 to 5. 5 4s, 5 4s, 5 4s, 5 4s. Okay. Okay. So with that said, we're down to our last example for the day. Copy this one, please. Evaluate the logarithmic function. This one has everything we saw just right now. Rewriting, solving, but now they're going to give us a value to substitute in a given function. So they give us the function f of x equals log 7 to find x. And they give us to evaluate f of 49, f of 1 over 343, and f of 7 square root of 7. So I'm going to start off with the first value, which is f of 49, but I need to rewrite my function. Here it goes. My function is f of x. So I'm going to write f of parentheses empty because I need to substitute for x. And I'm going to write log 7 and parentheses for the x. My first value, I'm going to use blue, is what? 49. I'll write it in here and write it in here. Okay, look up to the screen. So this is what I need to get started. Here it goes. To get started, pay attention to this part. Very important. This function notation needs to be changed to y form, which now it's going to read y equals log 7 to find the given number 49. We're like, okay, I think I see it now, Mr. Q. So from there, we need to rewrite it. What's our base? Our base is 7 to the y exponent equals to 49. From there, they need to have the same base. So 49 divided by 7 is 7. So this is 7 to the second equals to 7 to the y. So we write our equation. So y equals 2. That's how you evaluate a function. Let's go to the next one. I'm going to rewrite the same function, f of equals log 7 and parentheses. Next value I'm going to substitute in there is this one, 1 over 343, 1 over 343, 1 over 343. Okay, same steps. The first function notation needs to be changed to what? To y. We got log 7 to get the given number 1 over 343. All right, what's our base? 7 exponent of y equals 1 over 343. So these need to have the same base. So let's see, 343 divided by 7, that's 49. 49 divided by 7, that's 7. So that's 37. So this is 1 over 7 to the third equals to 7 to the y. We bring the 7 to the numerator. So this is 7 to the negative 3 equals to 7 to the y. Therefore, y equals negative 3. Woo, let's go. And the last one, here we go. F of equals log 7 parentheses. And now I'm going to substitute which value? 7 square root of 7. 7 square root of 7. 7 square root of 7. All right, first things first, we change the function notation to what? Y. We got log 7, and we got 7 square root of 7. So what is our base? 7 exponent of y, and we have 7 square root of 7. Can we rewrite this one? Yes. We got square root of 7 to the first times 7 to the second. All right, so what is 7 to the first, 7 to the second? That's 7 to the third times the exponent of, what is the radical worth? 1/2. Okay, so that is 7 to the 3/2 exponent. So this is 7 to the y, 7 to the y, 7 to the y, which means y is equal to 3/2. Whoo, let's go. I'm telling you, I told you that the concepts are going to start coming at you from 1 to 5. How comfortable do you feel with these? This is what your home play is going to be. Evaluating, also rewriting, and solving log functions. Okay, 5 4s, 5 4, 5 4, 5 4, 5 4s, and a 3 and a 1. Okay. All right, guys, that's our session for today. Once again, your home play, make sure you go to your Synchronous Code, get that, and also at Canvas, you're going to get the PDF for your home play. And that's our session for today. And I'll see you guys, when do we see it? Wednesday. Okay, have a good one. Peace. Bye.
Have a good day, Mr. Q.
You too. Bye.